So, evolving a probabilistic simulation. It's easy to understand how a bottom-up deterministic simulation can evolve, since all its components and their interactions are clearly defined. What's difficult for me to understand is how a top-down probabilistic simulation can evolve, since its components are only there in probability and are therefore not yet clearly defined. And if the components are not yet clearly defined, then it's also not clear how they will interact with each other to produce the next delta t. Can you shed some light on this? In other words, it seems to me that for a reality to evolve, its components must interact with each other. But how can certain components interact with each other if they are only there in probability?
Okay, I have a couple of things to comment on that. Is first about it's easy to understand how a bottom-up deterministic simulation can evolve. Well, if that bottom-up simulation is deterministic, then it can't evolve because it's deterministic. Things that are
Yes,
deterministic can't evolve.
it's already
They,
fixated.
everything is fixed
It's
because
stuck. Yeah.
you have rules, and it is a machine, and it just works by the rules. So if you know the initial conditions of everything and you know the rule set, from there on, you can compute everything that's going to happen to the end of time. So there is no room for evolution. It just is what it is. And everything that it becomes is because it has to become that, because that's what the rules say it has to be. So in that kind of a deterministic simulation, can't evolve. But if you don't have, the question is, if you don't have that, how do you know what's going to happen next? Right? A deterministic bottom-up simulation knows what's going to happen next. Next, the ball that's traveling this way will travel a little further. Next delta t, I know all the rules in the rule set, so I can say what everything's going to do in the next delta t. But if you have a probabilistic simulation, how do you know what's going to happen next? Well, the answer to that is that it takes a random draw from a probability distribution of the possibilities, and that's what happens next. That's how it does that. So it looks at all the possibilities that could happen. What could happen next? Okay, now when I say all, if if it's unlikely, then it's maybe not look at that, but well, let me go further. So it looks at all the possibilities. Then it looks at all the probabilities of each possibility, or the probability of each possibility, because all the possibilities aren't necessarily equal. It's not that these are all equally possible, they're just all possibilities. Some of them are more likely than others. So all the possibilities also have a probability attached to them. We have all the possibilities and all the probabilities of each of those possibilities. All right, and that defines the probable future. Now, what happens next? Random draw is taken from a probability distribution of all the possibilities. And that's what happens next. So what's happened next could be any number of things. And most of the time, because it's a random draw from a probability distribution, what that means is that the random draw will more likely pull out things that are more probable. It's not just a random draw from all the possibilities. It's just a random draw from a probability distribution of the possibilities, which makes the more likely it'll get the things that are more the random draw will pull out something that is more probable most of the time. But some of the time it may pull something out at the 10 sigma level, out on the end of a tail someplace, a 1 in a million. It might pull that out, a 1 in a million thing. And that's what will happen. And everybody will say, wow, isn't that weird? Nobody expected that, but it was possible, but it wasn't likely. But that doesn't happen very often because of the way the random draw is limited by probability. So that's how a world based on probability can function.
So the part where I get confused is how does this happen in those areas where no measurements are made? So, because you explained that this draw from the probability distribution gets taken as soon as a player requires something to be rendered to it. The universe was also evolving when there were no conscious layers observing it. And we still needed to progress the evolution of the universe. So, how does the system then progress that evolution if it doesn't have a determined state of things?
There weren't any IUOCs playing characters in the beginning because there were no characters. But there was a larger consciousness system who was running this simulation of the universe and its expansion, and who developed the rule set and the initial conditions, and then punched the run button and let this simulation run. Okay, so we had a larger consciousness system. And basically, it was looking at all the possibilities and taking random draws and letting them go. So, okay, what's probable? High temperature, high pressure, all in one little spot. Rule set says it's going to expand. Okay, so how much is it going to expand? Well, it depends on how much pressure, how much whatever. So it knows the rules. It takes the rules, it does random draw and says, all right, expanded like this. And then it said, this is boring and it's taking a long time. And we're going to spend a whole lot of time just getting this universe to go. So let's make delta t bigger. So delta t now can jump, what, millennia by millennia? It could, you could just speed things up, and it could take random draws, and now everything's happening faster. Every random draw is another 1,000 years gone by, So it could speed the process up as much as it wanted to by taking larger delta t's until the results started to get complex enough that those big changes were no longer a good idea. Once everything gets complex, now it matters what this little thing does over here because it's interacting with other things. There's a lot of interactions going on, so you need to get down to the level of interactions. So you start off really fast, let it evolve, just randomly, it goes. And then you slow it down and you give it as big a delta t that makes sense for this level of complexity and development and interaction. And eventually it becomes a universe, and it's got suns and it's got planets and so on. So that just happens in the system. One consciousness, that's the larger consciousness system, making those choices. Now, another thing happens also is that when you make a simulation like this, it's very hard to get the simulation to be stable for a long enough period of time to get the results you want. The result the system wanted was something that produced avatars that would be good for its IUOCs to play with. So if it turned out that it wasn't working very well, or that things were going haywire, it would just go in and twiddle a little bit with it, twiddle with the rule set, twiddle with the result, and say, well, this isn't working. I don't want that to happen. So it would change it. So there's no doubt that there was not just a rule set and initial conditions, and then it was hands off, let it go. That would be really, I think, too hard to expect it to really turn into anything in the long term. So I'm sure there was fiddling with it in the beginning in order to make it turn out the way the system wanted it. And I don't know whether this is true or not, but just came to mind as an example. Okay, you have gravity, and gravity basically all the masses. It's as if all the masses attract each other, right? That was Newton's idea of gravity. It's still basically true about the way it works. So all these masses, well, they're all blown out like this because of the high pressure, and it all goes out. But eventually, if all these things are like that, it's only going to go so far, and that's going to deaccelerate because there's forces pulling it back to where it started. So it's going to deaccelerate and stop, and then it's going to start coming back together again. And then you'll have what physicists call the big crunch, when it all comes back into the center, and then boom, it goes back out again. And they thought they had this idea that maybe it did that, but it doesn't do that. That's not the way it works. And not only is it not slowing down, which is what physicists thought of, 40 years ago, it ought to be slowing down. It's actually speeding up. It's accelerating. Well, why is that? Gravity can't explain that. So they made up dark energy and stuff like that. They just made up stuff to make it the way the experiments show that it is. So they just made some stuff up. We called that fudge. They fudged the equations by putting in what they needed to get the answer that they knew was right. So now we have those kinds of things. But I can see a system that says, all right, this is pretty good, but oh no, look, gravity's too strong and it's all going to crash. But if I make gravity any weaker, it won't work. It doesn't work well. So it's between a rock and a hard place. It just says, well, I'll fix that. I'll just let everything continue to accelerate. It's simple to do, in a simulation. You just fix things that don't work. So there's going to be these little unexplainable things that are going to happen along in our evolution, because the system's going to look at that and say, well, that's not what I want. This isn't going to work out the way I want. So let me fix that. And just the same way, if it just happened randomly that a big comet or something was going to hit the planet and kill everything, the system would say, nah, I don't want that. My experiment's still just bubbling along just good. Get rid of that comet. Just X that out of the simulation, because it's not helpful. So things like that, no doubt, happen because it's too hard to get this something to span for 5 billion years, and not have a catastrophe of some sort. So there's no doubt that the system the larger conscious system intervenes in the simulation to make it work out the way it wants it to work out. And that may be also an answer for like the missing links. We don't find a lot of monkeys that are half monkey, 100% monkey, 90% monkey, 80% monkey, 60% monkey, 50% monkey, all the way down to, a human. We have some kind of human thing going on here. We don't have all those things in between. We don't have monkeys, and then we have people. And it could be that those monkeys weren't just making it as far as being good enough, challenging for the individual unions of consciousness, and the system had to go in and tweak a few things and make it work better. And maybe that's why we are kind of different than the other animals in certain ways. So anyhow, I expect that those things kind of happen that way. All right. So a bottom-up deterministic simulation doesn't evolve. It can't evolve. It can't do anything. It's just done. From the instant it started, it was done. You have the Big Bang, but the rule set just says this is how it is. Can't be any other way, and no evolution evolved. So, one that comes from not necessarily the top down, but one that's statistical and probability based, you have to have an idea what happens next, and that's the random draw. Other than that, it's just how things interact. It's just the same way any virtual reality is computed. The Sims character gets out and he buys a beer, and the bartender gets the beer and slides it down the table, and it slides right on down until the customer reaches out and catches it as it goes by. And all that stuff is all simulated in the sense that it works. So you have people who are making choices, but the actual way that the choices get implemented, well, the system does that the way the system wants to do it. It's within the rule set because it has to stay within its rule set, but it can simulate the implementation of the choices in a way that is consistent with the rule set. So now we have people making choices. The implementation of those choices is simulated by the rule set, by the rendering engine, larger conscious system, in accordance with the rule set. And that kind of is how everything progresses and does evolve. Now, the choices change things. If I make a choice this way or that way, well, something different gets rendered because I do something differently down here. Now, we can evolve then. And we evolve according to the choices that we make. Consciousness, and according to the choices that we make in consciousness, we evolve our consciousness, but also the evolution inside the system evolves. The physical system is also evolving. Dodo birds are becoming extinct, and other things are maybe becoming, and we evolve in the same way. So we have rules, and we have a larger conscious system that kind of lets things, that renders things according to those rules. And then we let it see how the interactions go, what sort of interactions happen. And then we evolve by our choices. So that's kind of the way it goes. But a deterministic bottom-up simulation can't evolve. That's one of the things that makes it hard to give much credence to materialism, is because materialism has to be deterministic. So nothing has evolved. Of course, everything around us that we look at, we can see the evolution in it. We see the dolphin, has, or the porpoise, whatever the right name, has finger bones like this in its fins. Well, why does it have, not only just fingers bone, but knuckles, where all the knuckles, it's got knuckles and finger bones in its fin, which is silly. A fin doesn't need fingers with knuckles, with joints that can move, but it has them. And evolution says, well, that animal used to be on the land. It had feet and toes and stuff, and it went the other way. Instead of coming out of the water onto the land, it went from the land back into the water. So we know that there are unusual things that happen, but they happen because it's possible. It's a possibility. Now, the fact that thing came back from the land into the water and ended up like that may have been the 1 in a million draw. It may not be easy to explain, but all we can say is that it was possible. And anything that's possible could happen. It might not be likely to happen, but it can happen. And of all the billions and billions of things that had to happen in however old the Earth is, well, quite a few of them probably came from out under that tail. The 1 in a million gets drawn out of billions of things. The 1 in a million comes out thousands of times. So we have a lot of diversity, a lot of strangeness that sometimes is survivable, sometimes not. So if it's not survivable, it goes away. If it is, it continues on. So that kind of gives you a basis of a probabilistic simulation actually being realistic as far as evolution goes. It can evolve, whereas material can't evolve. To me, that makes the materialist just kind of a dead thing, can't do anything, can't evolve, can't grow, can't change, can't do anything. It just has no purpose, no point. You just can't come up with any value. Why would all that be going on, taking place, happening, and there's no value in it? There's no purpose in it. It's not accomplishing anything. It's just a machine unveiling what the rule set dictates. It has to be. All right. So what? What value does that have in it? Why would that even exist? Things don't exist without reasons. Everything that exists for some function that it does, some value that it offers, something that it contributes. And in materialism, you start with the null set, nothing, and you're watching the results of equations. That's all. Oh, yeah, look how those equations worked out. But okay, so is that entertaining to somebody somewhere or something? I don't know. It just doesn't seem to be much to build a theory on.
Yes. Okay, thank you, Tom. That solved that little lack of understanding for me.
I and MBT events Hope you liked this video. We will continue to post videos for free on my YouTube channel, but please understand, these videos are expensive to produce. They represent many thousands of hours of production and editing, as well as all the necessary audiovisual equipment, computers, and software. If you find something of significant value in our videos, please consider supporting their production through our Patreon account or through a one-time donation. It would be very much appreciated. The links are in the description below. Thank you.